The most famous ancient Greek literary account of the creation of the universe is Hesiod's Theogony. In brief, this is how it goes. In the beginning, there's just primeval chaos. Somehow, and it's not clear whether they're born from chaos or they just spring up, there come Gaia, the earth, Tartarus, the underworld or abyss in the depths of the earth, and Eros, that is love. Chaos specifically does produce Erebus, darkness, and Nyx, night. And somehow, through union in love, love exists now that we have Eros, Nyx and Erebus produce Aether, brightness, and Hemera, day. Gaia produces Uranus, the heavens, Aurea, the mountains, and Pontus, the sea. Gaia and Uranus then mate, and basically everything else is descended from them, including the Cyclopes, the Titans, who fight among themselves for many generations. Eventually, Zeus emerges a couple of generations later as king of the gods through a sort of standard issue mythological bloodbath of patricide and genital mutilation and other horrible things. And then finally, we're into the stable rule of the regular Olympian gods. Now, although literary accounts vary, for example, Homer says the ocean is the beginning of the gods, it's thought that this is probably quite a widespread account in its basic features. I'll just draw your attention to a few that I think are fairly interesting for our purposes. First, the use of love as a primeval force. We'll return to that when we look at Empedocles, who also thinks of love as very important as a force. Second, the fact that everything starts from chaos, which is quite different from later accounts of the beginning of the universe, which tend to see a kind of prime creative and ordered force behind it all. Third, and this is a feature of Homer's cosmogony too, if he has this idea of ocean and earth. Third is the idea of primeval parents being separated to make space for the rest of creation to live in. And as Martin West and others have noted, this is a feature of creation accounts from many cultures. For example, in Yoruba culture in West Africa, the creation myth also has two primary parent gods, Olorun the sky and Olokun the waters. In New Zealand, in Maori mythology, the two parents are the Sky Father, Ranganui, and the Earth Mother, Papatuanuku. And they're also separated by their children, as with the Greek story. Also, as with the Greek story, there's a lot of familial violence and a kind of primeval divine struggle in the Maori story. The other thing that I think is worth noting is that in the account from Hesiod, the earth produces the heavens, which is probably not our instinctive way of thinking about it, but might be quite important to remember when we're thinking about cosmology and astronomy, later in this lecture and in the following weeks. So, what is cosmogony and how is it different from cosmology? First, something on the words. Cosmos is always a hard word to translate, and conventionally it means universe or world. There's not always a strict distinction in Greek thought between the two, which kind of makes sense if you don't think of the universe as all that big. However, it also has the meaning of order or arrangement, and the root word still appears in modern words that have nothing to do with space, like cosmetic. Cosmology is just the logos, that is the reason of the cosmos, whereas cosmogony is the gonos, or birth, generation of the cosmos. In that sense, cosmogony focuses specifically on the origin of the universe and its development, either from nothingness or from chaos into an ordered whole, whereas cosmology is mostly about its settled structure. Because of the order meaning of cosmos, both words have an inherent sense that they're accounting for the ordered nature of the world or universe. Now, some among you will already be thinking, well, but doesn't this presuppose that the cosmos is orderly in some way? Yes, it does, and this brings us to an important point about how we use this terminology. So some terms, like cosmos, are used directly by our sources. In the language of the anthropologists, we would call these terms emic, E-M-I-C, which means that they come from inside the culture being studied. Some terms are not used by our sources, for example the term substance monist, which will come up later, but they are used by historians to identify a feature or a phenomenon. In the language of the anthropologists, we would call these terms etic, E-T-I-C, which means that they come from outside the culture being studied. Some terms, however, can be either emic or etic, depending on how and when they're being used. This is difficult, and it's not always obvious in which way a term is being used. Cosmogony is a good example of one such term. The Greek term cosmogonia is used sometimes in ancient sources and is therefore an emic term. It does in these uses have the connotations of order mentioned above. However, when we as modern people use the term cosmogony, which people do sometimes, we're both trying to capture something that the Greeks thought about, emic, and also trying to capture something about how other historians have used the term, etic. So this can get a bit bewildering, but it's worth bearing in mind throughout this series as we encounter a bunch of terms, some of them emic, some of them etic, and some of them both. So, cosmogony. Some cosmogonical accounts account for the absolute origin of things, like matter and time, as well as its orderedness. Others take it for granted that matter exists, but want to account only for its subjection into time and order. Some cosmogonical accounts argue for the existence of multiple universes, either simultaneously or serially, whereas some flatly deny the need for a start point and assert the eternality of the universe. Some of the questions they ask still persist today, particularly the question of the absolute creation of matter. Now, I talked a bit about the Milesians in week 1, and it's generally accepted that the first cosmogonical accounts, which don't rely on supernatural forces and which involve an invariant and consistent universe, are those of the Milesians, first among them Thales, or the first that we have, of course. Now, we can make a lot of the question of when something comes up first in a historical record. As I say, often it's just an accident of what we have. Maybe it's not actually that interesting. As I mentioned in the first lecture, we do still have this very vexed question of the Greek miracle and why these thinkers are giving natural and consistent explanations for the physical phenomena they see about them. But if we leave some of those questions aside for a moment, we can look at some of the features of the Milesian cosmogonical accounts. As a note, there's a good book by Andrew Gregory, which I will put on the bibliography at the end, which deals with a lot of this material and is particularly good on the pre-Socratic stuff. So let's begin at the beginning with Thales and the Milesians. Much of our testimony on Thales, and indeed the rest of the Milesians, comes from Aristotle, particularly from Metaphysics, Book 1, Chapter 3. Now, so some of it is we're not completely sure how accurately it captures real Milesian thought, but we can leave that aside a bit. A key feature of Milesian cosmogonical thinking, which I mentioned briefly in the first week, is the idea of the primary substance, which itself is eternal and has no absolute beginning or end. For Thales, this substance was water. This hypothesis is described as follows by Aristotle. So I quote, "There must be some natural substance, either one or many, which is preserved while other things come to be. On the umber and form of this arche, beginning or first cause, there's no agreement, but Thales, the originator of this sort of philosophy, said that it is water, and so declared the earth to be upon water." End quote. Aristotle says that Thales came up with this idea because he observed moisture to be the nurturing component of all living things, which themselves have a moist nature, and he believed that warmth comes from moisture. We're not really sure if this is actually the flow of causation in Thales' reasoning. This kind of reasoning works in an Aristotelian system, but it's not clear if Thales actually used it himself. However, other sources, including Cicero and the Stoic Heraclitus Homericus, back up that Thales did consider water to be the primary substance, so that bit at least we do know. He also apparently believed that soul pervaded the universe. For example, he's widely claimed to have believed that the lodestone, a kind of magnet, had soul because of its magnetic properties. Andrew Gregory reads this as meaning that soul was a quality of water, the primary substance. We don't, from this evidence, get much of an idea of how the cosmos came to be out of water. Let's move on to Anaximander, one of the other Milesians, in order to get a better picture of how this kind of cosmogony, where one element is the primary substance, actually works. So we have a bit more information about Anaximander than we do about Thales. We have this summary by Theophrastus, which is reported in a later work by Simplicius. So I quote, "Of those who say the universe is one, in motion and unlimited, Anaximander, son of Praxeades of Miletus, was a follower and student of Thales. He said that the arche, an element of existing things, was the unlimited to our pairon. He says this is not water nor any of the other so-called elements, but some other unlimited nature from which are generated all the heavens and the cosmos in them. End quote. As you see here, Anaximander, or in this account, Anaximander is positing not a fundamental element, but a sort of principle that's not itself an element in the way we'd think of. It's not like water. It's more of a kind of abstract principle from which things come into being and into which things go out of being. What exactly this means is hotly contested. This theory has been quite popular among philosophers throughout history. Both Nietzsche and Heidegger were very interested in this. They both take this cosmogonical insight as being hugely important, and they discuss it quite extensively. Pseudo-Plutarch, back in antiquity, gives a more specific explanation, although it's hard to know how accurately it represents Anaximander's views of how this works regarding the cosmos. So I quote, Anaximander says, that which is productive out of the eternal hot and cold was separated at the genesis of this cosmos, and that a sphere of flame was formed around the air. A sphere of flame was formed around the air, around the earth, like a bark around a tree. When this was broken off and enclosed in certain circles, the sun, moon, and stars were formed. End quote. From this evidence, and some in Aristotle, we also begin to get a picture of Anaximander's cosmology, that is, how he thinks the cosmos, once it's come into being, is structured. I'll spend a bit of time on this, as there's been some scholarly disagreement over exactly what the model was, and it's quite a good case study for how unintuitive some pre-Socratic thinking can be, and indeed how fragmentary our evidence of these things really is. Anaximander's cosmological model of the universe is, to modernise, quite eccentric. So I'm going to put a diagram up on the screen now, and I'll take you through it before I explain some other options, some various options for interpreting it. So we've got a cylindrical Earth at the centre, which is 3 times as wide as it is deep, and that's specified. It's surrounded by a series of concentric rings, whose radiuses are, for the first one, 9 times that of the Earth, the second one 18 times that of the Earth, and the last one 27 times that of the Earth. Here's where the disagreement begins. Some people put the rings horizontal, i.e. parallel to the Earth's surface. I've put them in my diagram vertical, on the grounds that his argument depends on people being able to see them. Some people have suggested that Anaximander knew about the ecliptic, or at the very least that the zodiac was at an incline, that is, the tilt of the Earth. So maybe the rings should be at an incline, 23 degrees, the tilt of the Earth. We'll come back to this next week. We don't really know what Anaximander intended here. We just know that there were these rings and the Earth. So the rings contain fire and they're pierced, and it's the holes in the rings through which we see the fire, and those are the stars. Now, in Anaximander's model, the closest ring is the fixed stars, the next is the moon, and the next is the sun. We don't know how wide the rings themselves are meant to be, whether they're meant to be kind of a broad swathe taking up most of the sky. If the rings are opaque, then obviously we've got a problem. We wouldn't be able to see anything beyond the fixed stars. And I don't think Anaximander wouldn't have thought of this. So some scholars say maybe the rings are kind of transparent, and it's only when you see the pierced bit in the ring that you see the fire inside. Some scholars say that the rings move up and down along the axis of the Earth. It seems likely that he did mean the rings to be crystalline in some way, so you can see through them, but yeah, you can't see the fire inside until it's pierced. It's just not clear. What's interesting about this model is not only that in itself it's an attempt to fit all the phenomena. For example, we know that Anaximander said, when explaining various kind of bits and pieces and how it worked with this model, he said that eclipses are when the holes in the rings are occluded, which, seems to work. But also what's interesting is that his argument about the Earth's position at the centre of the universe is quite unusual. So I mentioned earlier that Thales thought that water was the primary element, and he made arguments about the Earth resting on water, which explained its position. Anaximander, by contrast, argued that the Earth was able to stay unsupported at the centre of the universe because it was equally distant from all other things. It's also not wholly clear what he means by this. So many pre-Socratic cosmologies prior to Anaximander, and indeed after him, have the Earth resting on something, and they don't have the conception of the Earth just being self-supporting. It's either on some kind of pillar, or it's on water, or it's resting on something. There's a clear up and down to the universe, whereas for Anaximander, it just stays there. So Karl Popper was a very big fan of this theory of Anaximander's, and defines it as the first scientific breakthrough on the grounds that it presents a significant advancement, in Popper's view, on Thales' notion of the Earth being supported by water. The problem, according to Popper, is that Thales' view invites infinite regress. You say, well, if the Earth's on water, what's the water on? Anaximander, by attempting to answer such an infinite regress, is fully engaging in what Popper thinks of as scientific discourse. And I'll just quote to you what Popper says in a book called The World of Parmenides, which is a series of essays written between the 1960s and the 1990s. So I quote, "In my opinion, this idea of Anaximander's is one of the boldest, most revolutionary, and most portentous ideas in the whole history of human thought. It made possible the theories of Aristarchus and Copernicus. But the step taken by Anaximander was even more difficult and audacious than the one taken by Aristarchus and Copernicus. To envisage the Earth as freely poised in mid-space, and to say that it remains motionless because of its equidistance or equilibrium, as Aristotle paraphrases Anaximander, is to anticipate, to some extent, even Newton's idea of immaterial and indivisible gravitational forces." It may not surprise you to hear, having heard my first lecture, that I really dislike this style of claiming importance for ancient, the rhetoric of claiming importance for an ancient scientific thinker like this. In particular, like many other historians of science, I'm not a fan of the use of the term anticipate here. What's Popper really claiming? Is he saying that Anaximander was trying to do the same thing as Newton? Absolutely not. Nevertheless, I think that despite that, Popper's basic point that Anaximander is trying to answer the fundamental problems of Thales' system, and doing so in a philosophically creative way, is certainly important for the later history of Greek cosmogony and the way in which scientific discourse, that is to say, the discourse of refutation, as mentioned in the first week, how that develops in the Greek world. Anaximenes, who's usually thought of as the third of the Milesians, although he was actually probably a contemporary of Anaximander, has another cosmology, and his cosmology is actually a bit more similar to Thales in his thinking, except instead of water as the prime element, he instead argues that it's air. Here's another summary from Theophrastus, again quoted in Simplicius. So I quote, "Anaximenes, son of Eurystratus of Miletus, a companion of Anaximander, says like him that the underlying nature is one and unlimited, although unlike Anaximander that is, it is not undefined, as he says it is air. It differs in its nature by being more rare or more dense. Becoming rarer, fire is generated. Becoming denser, wind, then cloud, and denser still, water, then earth, then stones, other things being generated from these." End quote. We see here that Anaximenes has a sort of top-down cosmogony in which matter becomes, more material gradually, in a sort of gradation of creation from air down to solid earth. I think it's quite an attractive theory because it does seem to bridge the ontological gap between nothingness and somethingness that we saw thinkers grappling with, not only the Milesians, but slightly later on the Eleatic skeptics who I spoke about last week. But the problem with this theory, of course, is that it raises a lot more questions than it answers. And indeed, those are not just problems that we moderns have with this kind of primal element steering the world into order theory that's so popular with Milesians, but problems that those in the generations after them raised. And you saw some of them when I talked last week about Parmenides and Zeno and the sceptical questions they raised. Going onwards from them, many of the thinkers I'll discuss next had to reckon with those questions both when they commented on Milesian theories and when they developed their own. One of the next pre-Socratic cosmologies we know about is that of Empedocles. Empedocles is often known as the first thinker to posit a four-element system with the kind of classic elements that we now know. We knew for a long time were the kind of medieval four elements as well. And those are earth, air, fire, and water. And that element system formed the basis of chemistry until the Renaissance. Empedocles was of the generation before Socrates and was hugely influential to Plato and later thinkers. His main cosmogonical innovation is the idea of cyclical cosmoses. That is, cyclical in a time sense. So a cosmos is generated, exists for a while, then degenerates in an eternal cycle. The Empedoclean cosmogonical explanation goes something like this. There's two competing eternal forces, philotes, love, and nekos, strife, which eternally and continually mix and separate the four elements, which are constitutive of the whole material world. Love and strife, as equal and opposite forces, sometimes wax and sometimes wane in terms of their power, but neither one ever wins outright. Empedocles posited that when elements combined in ways that fit well together, such as in the case of some types of animal or human bodies, then they were able to remain stably there, poised between love and strife. And when they didn't fit well together, well, they would disintegrate. So this is an account of how things change, how some forms are stable and how some forms are unstable. And you can see with the use of love and strife is a bit like chaos. It draws on these kind of mythological accounts, and of course, worth bearing in mind that mythological and scientific are not really separate in this period. A major feature of Empedocles' thought is a focus on reincarnation, similar to the beliefs in reincarnation found among the Pythagoreans. It's been a long-standing problem to decipher how this fits with Empedocles' cosmology. Simon Trepanier, who's an expert on Empedocles, has argued that Empedocles' complex cosmology is highly linked to his eschatology, that is, his beliefs about the afterlives and journeys of human souls. Trepanier argues, and I'll put this item on your bibliography, that Empedocles situates the current life of human beings in Hades, the underworld, and sees the journey of the soul as a kind of cosmic ascent towards the earth and then finally to the heavens. In this model, says Trepanier, we should understand the gods, who are not strictly speaking immortal in Empedocles' thought, but just long-lived, as the stars. As with the Milesians, Empedocles' corpus is very fragmentary. We've got some papyri and various attestations in other writers, and like many other writers of the time, he writes in hexameter epic, which might seem an unnatural choice to a modern eye for a medium of scientific writing, but as you'll know, was really the norm in this period. Nevertheless, it does make it occasionally quite hard to decipher what's going on. I'm not going to spend any more time. I could talk more about Empedocles, but I'm not going to spend any more time on him. Instead, I'm going to move on and talk a little bit about the atomists. The other people I should mention briefly are the atomists. In week 1, I talked very briefly about Democritus, Leucippus, and then Epicurus and Lucretius, and their innovative notion that matter was not continuous and unbounded, but instead discrete little lumps called atoms floating about in an emptiness called void. If we actually look to the texts, we can see more. Those we have surviving are some fragments of Epicurus and a much longer poem by Lucretius, which is generally thought to be roughly translating, or at least heavily influenced by Epicurus's work, but with a lot of Lucretius's own glosses and ideas. We do have a fragment of Epicurus preserved by Diogenes Laertius that sets out his basic position, which is as follows, quote, "Besides bodies and void, there is nothing whose essential nature we can conceive of by reason or any similar process." When put beside Lucretius's basic position, it's actually quite an interesting contrast. Here's Lucretius, quote, "All of nature as it is consists therefore of two things, bodies and void," end quote. You'll notice that these are actually subtly different claims. While Lucretius is saying that there actually exist only atoms and void, Epicurus is saying that we cannot conceive of anything else. Now, this may or may not be that important, but I think it does show you that Epicurus, who comes in a generation after the Eleatic skeptics, when he puts forward his cosmology, is extremely cautious about the epistemological basis of what he's saying. I'm not going to talk a lot more about atomism, even though I could. These theories will become very important later, but what's actually quite surprising about atomism this period is that the atomists didn't seem to have a very big effect. So instead, I'm going to move on and talk at some more length about Plato and Aristotle. Plato's cosmology is famously complicated. It's set out in its fullest form in the Timaeus. Let me give you a truncated run-through of how it works. So there's a lot of stuff to do with the fates and a kind of spinning astrological wheel that I'm not going to get into now, although may mention next week. But throughout, Plato, it's worth bearing in mind that Plato is totally on board with astrology, which will be important next week. So here's how it basically works. Matter is eternal and uncreated. There's a demiurge who's a kind of divine craftsman who imposes order on the pre-existent chaos and makes the world, which is itself a living creature with a soul called the world soul. The world is a sphere. For Plato, the sphere is the most perfect of the shapes because it's the most omnimorphic of all the figures. That's to say, he thinks it can encompass all the other figures. The primary defining motion in Platonic cosmology is circular motion, which he also considers to be the most perfect kind of motion. This will also become incredibly important for astronomy, and I'll come back to it next week. The four elements in the Platonic cosmos are the same as the Empedoclean four elements, that is, earth, air, water, and fire, and from now on, after Plato, these become the absolutely dominant model of thinking about elements. The four elements interact in harmony. Each of these elements has a specific geometrical makeup in Platonic physics, and so they're all made up of combinations of triangles. So, for example, fire is tetrahedral, air is octahedral, water's icosahedral, and earth is a cube. Together with the dodecahedron, which represented the mysterious fifth element, ether, upon which Plato doesn't elaborate, these make up what we know as the Platonic solids. The sphere, the shape of the world, is of course the most perfect shape, and that's superior to the Platonic solids. In Platonic physics, the constituent triangles of each element can also break down. They're sort of sub-elemental structures. So an element can break into its constituent triangles, and then those triangles can recombine to form a different element. This possibility accounts for the combination of elements with one another and the changes of state that we see of materials from one element to another. So water's ability to put out fire, for example, is in a Platonic reading to do with the interaction of their constituent triangles. Sometimes this system works quite subtly. Sometimes Plato's explanations seem kind of dumb. For example, sharp things are sharp because they're made such that their constituent triangles are particularly pointy. Nevertheless, the real innovation here is to suppose a geometrical, that is a mathematical, regular and rational system at the sub-elemental level. This notion that physical processes can be understood as mathematical abstractions is the insight that allowed in Plato's school the full mathematization of many scientific disciplines, including things like astronomy. You'll note that this has links to what I spoke about last week, and the idea of mathematical objects and the knowledge we can have of mathematical objects. And so for Plato, mathematical objects are an important bridge between the world of the forms and the sensible world. So for him, having this underlying rational mathematical structure to the world is kind of one of those bridge points that gets us from the noumenal world of the forms to the seemingly irrational sensible world. I'm not going to say more on Plato. I'm going to go on to Aristotle because I'm going to talk about Aristotle at some length. So, Aristotle's cosmology. Like Plato, Aristotle believed in the eternality of matter. Instead of the demiurge, who was the kind of divine craftsman in Plato, Aristotle has what he calls the unmoved mover. And those of you who have read some Aristotle will know that Aristotle is actually extremely vague in his ideas about the divine and the unmoved mover. So I'm not going to go too much into the precise philosophical differences, but the takeaway here is that in both Aristotle's case and Plato's case, the cosmos is made of eternal matter, which has been ordered by an active intellect. And you can see that's in contrast to the Milesian system, where matter is created and comes from an underlying principle. So for Aristotle, the universe splits into two sections, and he tends to talk about these two sections quite separately. There's what he calls the sublunary sphere, which contains everything beneath the moon. So if you kind of drew a circle from the moon, everything downwards, including the Earth, is in the sublunary sphere. And then everything further up than the moon is the celestial sphere. The texts dealing with this are Aristotle's physics, his De Caelo, and his meteorology. The physics deals with the whole system. The De Caelo focuses specifically on the celestial sphere, and the meteorology talks quite a lot about the sublunary sphere. Let's start with the sublunary sphere. So Aristotle subscribes, like Plato, to the Empedoclean four-element theory. But his physics, or perhaps we'd like to call it his chemistry, doesn't go with the kind of sub-elemental geometrical thing that Plato does. He talks in a lot more detail about how the elements interact, and he seems to see the elements as themselves the basic building blocks. And he has quite a different theory from Plato about how elements interact and combine with each other. The four elements, as you know, as I've mentioned several times, are earth, air, fire, and water. And Aristotle arranges these elements in pairs. So earth and water tend to be paired together, fire and air tend to be paired together. And he ascribes to these elements corresponding qualities. So cold and hot, dry and wet. So, for example, the element of earth is cold and dry. The element of water he thinks of as hot and wet. Fire he thinks of as hot and dry. And air he thinks of as cold and wet. Now, that's maybe a little unintuitive to some of you, but the point is that you've got these four elements who can be grouped into pairs, and they have these pairs of qualities, but the qualities are in pairs that kind of cross over the element pairs, if you see what I mean. So there's a kind of balance within the system. Now, these four elements have their natural motions. For earth and water, their motion is centripetal, that is, they tend towards the centre of the earth. Whereas for the light elements, fire and air, their motion is centrifugal. They tend tend outwards, away from the centre of the earth. And by having this system, again, it's a system of balanced pairs, Aristotle says that motion overall is balanced between the four elements. So each has its kind of telos of position, and you'll recognise the word telos in its technical sense as I used it in the first lecture to talk about kind of the end point. And the telos of position of the elements is a kind of natural tendency towards either the centre or the boundaries of the universe. On the screen now is a diagram of Aristotle's cosmology. So he says, so Earth is at the centre of the universe. We've got a big chunk of Earth, and that's what we think of as the Earth. The element Earth is mainly focused in the centre of the universe. Earth is paired with water, and so water forms not only the oceans, rivers, lakes, and so on, but is constantly interacting with land. The region between the surface of the Earth and the Moon is made up, according to Aristotle, of a combination of fire and air. Closer to the Earth's surface, it's nearly all air, and that's the air we breathe and walk around in. And air interacts as well with water to form clouds and so on. Further away from the surface, closer to the Moon, we get more and more fire, because fire is the lightest element. Noticeably, Aristotle points out this is not actually fire as we know it on Earth, but we call it that for its potential to become flame. Later writers commenting on Aristotle, including John Philoponus, who's a late antique Christian commentator, use the term the tinder sphere to refer to this capability, this kind of thin layer of fire around the outside of the sublunary sphere. And that's what I've put on the diagram, and that's why it's kind of a bit faded out. Aristotle notes that the fire and air are constantly interacting and moving in and out of one another. Now, look, clearly Aristotle knew that there was not a separate layer of fire above the Earth. If there were, we'd be able to see it. What he's really talking about here is a sort of natural positioning for both fire and air, which are constantly interacting with each other. If we move on to the celestial sphere, things are a bit different. The celestial sphere is made out of a fifth element, ether. As you'll remember, ether was briefly mentioned in Plato, but he didn't elaborate on it in any detail. Aristotle talks quite a lot more about ether, and I think it's a very smart move. So Aristotle's sublunary physics depends on an interaction of opposites, where we've had the elements in pairs, the qualities in pairs, everything having its telos, everything being balanced, moving in and out of each other. And every element has its opposite both in essence, in that way, and in properties. So dynamic tension kind of holds everything in constant flux and motion. Now, Aristotle posits the celestial sphere as the opposite to the sublunary sphere. So the material of the celestial sphere, ether, is thus opposite to all four of the four elements, both in essence and in property. So he calls this ether, following Plato. He says it's immutable, unlike the sublunary elements. It's eternal, again, unlike the sublunary elements. And as such, its motion is circular, unlike the sublunary elements. Circular motion is also a very neat move. It's opposite, in some sense, to rectilinear motion. So the motions of the elements, the sublunary elements, were either inwards or outwards, whereas circular he conceives of as opposite to those types of motion. But also more than that, it's representative of eternality and immutability too, both as a motion that has no end and no beginning, eternal, but also as unchanging change. It's kind of always moving, always going, but it's kind of never really changing. So it's a celestial sphere that's physically moving, but always keeping the same distance from the centre of the universe, always repeating the same path. In this, Aristotle's also keeping circular motion as vitally important as Plato did. So despite being opposite to the sublunary matter, ether can and does interact with the sublunary stuff. For the stars and the sun, which are also made of ether, to produce heat, they must produce some kind of friction, which sets the upper layer of the sublunary sphere alight. This is what Philoponus called the tinder sphere. And so this is how you get the phenomenon of, for example, comets, which are flashes of fire, which are caused by the interaction of the heavenly spheres with the sublunary, and they kindle the upper air briefly into flames. It's in this way, says Aristotle, that we feel heat on Earth, despite the fact that the sun and stars are not made of fire, because in this model, the motion of the celestial sphere is what causes the sublunary processes. I mentioned earlier the idea of ekpyrosis, or the idea of cyclical cosmoi that burn up and come back again. And that's the fundamental Stoic belief about the cosmos. So they have a belief that there's a succession of the cosmoi that periodically burn up and are re-established. They call it ekpyrosis. This comes along mostly with a belief in fate, in a deterministic system, and so you can see how those things fit together quite well. You have a world in which a certain number of things happen, and then the world comes to an end, is rekindled, and the same thing happens again, and it's determined because it has in fact already happened. It's important to note that different Stoics have slightly different cosmologies, but this is certainly quite a prevalent line of thinking. Although Stoic cosmology is pretty similar in other ways, in the more of its details about the physical structure of matter and the elements and so on, it's pretty similar to Aristotle's. But instead of ether, they have a different fifth element. They have this substance they call pneuma, which is also, for them, the stuff that human souls are made up of. In this system, the fact that human souls and the heavens have basically the same material makeup becomes very important. We'll return to that in the next chapter when I talk about astrology, but it makes the idea that there's some kind of interconnectedness, even some kind of action at a distance, possible between the heavens and human souls. Well, it doesn't sound so ridiculous. In particular, an example I like a lot is there's a part in Seneca's Thyestes. Seneca, obviously a Stoic philosopher. There's a part in the Thyestes where he's talking about the mythological story of Thyestes, who eats his own children, and he doesn't realise he's doing so. They're in a pie. And at this point in Seneca's description, the heavens just stop where they are. They're looking down in horror, and the rest of the day just passes in a blink. The heavens just are like, no, we're done with this, and finish the day. Now, that's often taken to be a kind of literary invention, but if you have this notion that the heavens are made of the same stuff as human souls, and if you have the astrological notion that the heavens can affect human beings by means of this connection between the pneuma above and the pneuma in us, then it doesn't sound so silly to say it could happen the other way round, i.e. a huge and egregious moral failing on Earth carried out by a human being through the pneuma connection could have an effect on the heavens. Interesting. Relatedly to the pneuma thing, the Stoics also have the notion of the world soul that we saw in Plato as well. Their idea of the world soul is slightly different, but and it's not usually talked about in those terms, but it's the idea that the whole universe is a kind of ensouled being and that all components are interconnected. This will later become hugely important for Neoplatonism, which takes its cue both from kind of traditional Platonism but also lots of Stoic elements. But I don't think there's really time to talk about it now, so I will just sum up before the end. So in this lecture, I've talked a bit about cosmogony and cosmology, and we saw that the early cosmogonical and cosmological theories of the Milesians tended to have this kind of what's called substance monist approach, where they say there's this one primary substance and everything else comes from it, whether that's water in Thales, the to apeiron, the boundless in Anaximenes, or air in the boundless in Anaximander, or air in Anaximenes. And then we see the kind of four-element theory appearing in Empedocles, and that gets adopted, as we saw, in Plato and Aristotle. Now, Plato and Aristotle have these cosmologies with these points of overlap, like the four elements, but quite different kind of substructures. For Plato, the four elements are made up of constituent triangles, which are kind of a mathematization of the physical world, and these constituent triangles can break down and recombine and interact, and that explains change. And as you can remember from last week, one of the things that the skeptics brought up was this problem of how do you know what there is? How do you know how can there be differentiated matter, and how can there be more than one thing? That was the Parmenidean challenge. And then in Zeno, the challenge of what does it mean for something to be in motion? What does it mean for something to change? And in both of them, what does it mean for something to come out of nothing or for something to change state? So Plato's answer is, okay, we have this underlying mathematical structure, and that's how change happens. Aristotle's answer is a bit more like chemistry. He talks about the properties and the qualities of the elements and how they're all balanced and they're all interacting, which was a bit more like Empedocles with this idea of love and strife kind of holding everything together. And then you've got this separate strand of the atomists kind of doing their thing with just matter and void, but that doesn't have a huge impact until later. And then you've got the Stoics, who are taking, again, 4-element theory, but instead of ether, they've got pneuma, and they tie that to human souls. So those are the cosmogonies and cosmologies we've talked about. And then next week I will be sticking with the kind of cosmic theme and talking about astronomy and astrology.